All right, welcome back to Math 098. So we are going to continue investigating our understanding of graphing linear equations using slope-intercept form. Pretty soon we're actually going to learn how to write an equation. So we're going to essentially go backwards. We're going to look at information that is provided to us, and using that information, we are going to write out this specific equation pertaining to that. So let's pick up where we left off, which was in number 2 from last class. We started this section on this page where we wanted to combine all the things that we've learned from Unit 4 so far. We wanted to graph by identifying the slope, the x and the y-intercepts. We wanted to then state the slope of a line that was parallel and state the slope of a line that is perpendicular to the one that we drew. So we didn't get a chance to do number 2 in class together, and I asked you all to please take that home and see how you do. So we're going to investigate together right now, number 2, and what I'm going to do is I'm going to showcase a perspective that you could take. So what I would do personally if I saw a problem like this. So let's check it out. So we have y minus 5 is equal to negative 3/4 x. Now, the interesting thing about this is we know for a fact that this is not in standard form, right? If it were in standard form, my y should be on the same side with my x term. But that's not really essential, right? It's not like the goal is, hey, let's get our equation in standard form. That's not the goal. So what we could do instead is say, well, I'm actually pretty close to slope-intercept form. In order to do that, Kayla, great question. This actually can be considered point slope form. I love that, Kayla. Thank you so much for presenting that to the class. That won't mean anything to anyone yet, but when you see what point slope form actually is and how we play around with this, I think you're about to say, oh, damn, Kayla was on the right track with that. She's exactly correct. So what we're going to do here is, considering what we know so far, is why don't we get this in slope-intercept form? And we can do this by adding 5 to both sides. So I'm going to start here. If I add 5 to both sides, notice that leaves me with y is equal to negative 3/4 x plus 5. Now, the really cool thing about this is that we know how to graph given this information. So right away, I can note that my slope is negative 3/4, right? It's the m in our y equals mx plus b. So negative 3/4 is my slope. And then, because this is slope-intercept form, if my slope is a negative 3/4, my y-intercept is 0.5. So I'm actually going to write that out as well. Now, given that information, I can graph this. So why not? Let's start there. So we have to begin by plotting the point 0.5. So we know 0.5 is going to be on the y-axis. So 0, 1, 2, 3, 4, 5. Here we go. There's my point. There's my y-intercept. And now I'm going to apply the slope. We know that it's a negative 3/4. So this implies we fall 3 and run 4. Remember, we always run to the right. So I'm going to fall 3 units from this point. We're going to fall 1, 2, 3, and then run 4. 1, 2, 3, 4. Next, we're going to connect these with a straight edge. I'm going to do the best I can with this thing. I don't know why I don't just get out a ruler. Just trying to be creative here. Okay, and voila, there it is. Boom. We have the slope, we have the y-intercept. Now, we don't know the x-intercept, so we still have to calculate that. And if we follow this 1, 2, 3 over 1, 2, 3, 4, we see that we're not totally sure where it crosses the x-axis. It seems like it's somewhere near 1, 2, 3, 4, 5, 6, 7. It seems like it's around 7, but I actually don't know that for certain. So I can't just make that guess. I have to prove this algebraically. As a reminder, to find the x-intercept, we know that y must be 0. So let's go ahead and plug in 0 for y and see what happens. 0 is equal to negative 3/4 x plus 5. At this point, if I wanted to, I can multiply every term by 4, or I could bring over the 5. Totally up to you. To make things a little bit different from what we've done before, I'm just going to multiply every term by 4 first. So multiply, 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 right? That's one of the rules for solving linear equations. We're allowed to multiply every term by the LCD. So I'm going to start by multiplying by 4. 4 times 0, 0. If you said 4, be careful. 4 times 0 is 0, not 4. Numerator, denominator, 4 divided into 4 leaves you with 1. So 1 times negative 3x is just negative 3x. And then 4 times 5 is 20. Excellent. Now we have to solve for x. So I could bring the 20 over, or I could bring the negative 3x over by adding it to both sides. Again, just to showcase what we're allowed to do, I'm going to move the 3x. So we are left with 0 plus 3x, which is 3x, is equal to, these two are opposites, and that leaves me with 20. So opposites cancel, leaving you with a 0. 0 plus 20 is 20. Now that we have 3x is equal to 20, I'm going to divide both sides by 3, and x is equal to 20/3. The really cool thing about this, everyone, is that I don't have to write this as a decimal because I already graphed, right? No problem, Noelia. Thank you for letting me know. I already graphed the line, so it is not essential for me to try to figure out what 20 over 3 is, although I could if I simply plug this into my calculator. But really, because we were identifying the x-intercept, I'm actually going to write 20 over 3 comma 0. There is my x-intercept. Perfect. So part A, identify the slope, done. Part B, identify the x and the y-intercepts. We knew what the y-intercept base was based on the equation. Hi, Rachel. And then we calculated the x-intercept by plugging 0 in for y. The next thing we have to do is identify the slope of a line that is parallel and the slope of a line that is perpendicular to this one. So let's write parallel. That slope is going to be the exact same. So we went down 3 units and we ran 4, so the slope was a negative 3/4 for our line. So a line that's parallel will have the same slope. If we want to reference the slope of a line that is perpendicular, recall that 2 things have to happen. So visually, the line would cross at a 90-degree angle. Let me move this over just so you could see it. It would cross at exactly a 90-degree angle, which means the slope is definitely positive. That's the first thing we know. So it's not a negative, it's going to be a positive. And then the other thing is we have to flip the fraction. So it's got to be the opposite reciprocal. So it's going to be a positive 4 over 3. And that is the slope of a line perpendicular. Very nice. So this concludes putting everything that we've done so far together. So let's continue by, oops, I flipped too many pages. Let's continue by writing the equation of a line. So I had hinted at the fact at the very beginning, I had hinted at the fact that we have to now learn how to essentially go backwards, right? So this time, given specific information, I want us to write the equation of the line. Okay, notice the instructions. Write the equation of a line in slope-intercept form. It's always helpful to identify what it is that's being asked. So I would actually personally write y equals mx plus b above the slope-intercept form. It helps us to kind of keep in mind, oh, that's what we're looking for. That's the direction I need to head in. So then we say, okay, well, what are they telling us? Well, they're telling us that the slope is a negative 1/2 and the y-intercept is 0, negative 5. Okay, that's cool. So if I want to write the equation of the line, well, no big deal. I know that slope is m is a negative 1/2. So I'm just going to write here that m is a negative 1/2. And I know that the b is my y-intercept, and my y-intercept is 0, -5. So that means my b is a -5. So the equation of my line in slope-intercept form is simply y is equal to, yes, Claire, excellent, -1/2 x minus 5. In this case, we don't actually need to write plus a -5. If you wanted to, just simplify that and make that a -5. Awesome. Take a look at number 2. This time, instead of saying we have the slope, we're told that m is equal to 2/5, which we should know is slope. And we're still told that the y-intercept is 0, 3/7. So again, if you would like, we already have that m is 2/5, so we can note here that b is 3/7. So given this information, we have enough to write the equation of a line in slope-intercept form. Y is equal to 2/5 x plus 3/7. Not bad, right? Given the slope, given the y-intercept, beautiful, no big deal. Now take a look at number 3. This is actually very interesting. Number 3 again gives us a slope -10, but this time it says going through 0, -2. Now the reason I wanted to share this particular problem is that sometimes, and actually more often than not, you will not be told that that ordered pair is a y-intercept. You just have to know. You have to know that the point 0, -2 is a y-intercept, right? This point 0, -2 is a point on the y-axis. So if a line goes through that point, then that point represents the y-intercept. So again, we have m is equal to -10, and we could say that b, our y-intercept, is a -2. And we know that because this is the form for a y-intercept. So I'm going to write y-intercept. Because it didn't tell us, but we need to know this. Okay, so having said that, we can now write the equation of a line in slope-intercept form. Y is equal to -10x minus 2. Now, what we're about to face is, yes, Gia, perfect. What we're about to face is what happens when that going through part, that ordered pair, is not a y-intercept. We're about to say, well, what do I do if they give me the slope, but then they give me some random point on the graph and it's not a y-intercept? Or what do we do if they don't tell us the slope at all? What if they just tell us 2 points that the line goes through? How do I find the equation of a line in slope-intercept form? Well, that's where point slope comes in. Think of the name, point slope, right? To use point slope, you need a point, meaning an ordered pair, and you need a slope. If you have those 2 things, you can use point slope. Think of the name slope-intercept form. To use slope-intercept form, you need a slope and you need an intercept, specifically a y-intercept, slope-intercept. Oftentimes I'll have students ask me, when do I use what? And then I say to them, well, think of the name. Slope-intercept, you need a slope and an intercept. Point slope, you need a point and a slope. Okay? Think of it like that. You're going to be golden. Just be very logical. Let's check it out. Point slope form is as follows. Y minus y sub 1 equals m times x minus x sub 1. Point slope has parentheses. Okay? If you want to write your form in point slope form, if you want to write your equation, in point slope form, make sure you have your parentheses in there. Okay, there are only a couple exceptions, but make sure that your parentheses are in there. Now, we are going to use point slope form when we have a point and a slope. What do you know? If you have a point and a slope, you use point slope. Okay, let's see this. Write the equation of a line in point-slope form and slope-intercept form going through -2, 6 with a slope of 3. So right away I say, oh, that's a point, that's a slope, point slope, okay? So because this is my point, I'm going to label this x1, y1, right? Every ordered pair is of the form x, then y. And we know that our slope is 3, so I'm just going to call that m. Now I'm going to use point slope form. So that's the first thing we're going to do here. I'm going to write point slope form. And then I'm going to write the formula. And I want you to do the same thing because I want you to commit this to memory. I want you to get enough practice where point slope form is just part of your everyday knowledge. So we have y minus y1 is equal to m times x minus x1. Okay, y minus y sub 1 is equal to m times x minus x sub 1. Now I want you to notice something. The only pieces of information I have are x sub 1, y sub 1, and m. 1, 2, 3 pieces of information. When you look at your formula, we have 1, 2, 3, 4, 5 unknowns. Well, because we need to come up with the equation of the line, this y and this x, the ones without subscripts, remain untouched. They will never be touched, okay? Y and x will remain y and x. The reason for that is we need to have the opportunity or the ability to plug in values. So we need to have the ability to have an input and an output, right? So if we take away the input and the output, you just have an evaluation, you just have a value. So we need to have an equation that essentially is a function. So let's take a look. Y minus y1 in this case is 6. So it's y minus 6 is equal to m is 3, parentheses, x is x, right? Recall, we just said we do not change the value here. See, Asia, no big deal. It's okay. And then we have minus x1. So minus, but x1 is a -2. So if I had a minus -2, do you all agree that minus -2 is the same as plus 2? And that is your equation in point slope form. Okay, so I'm going to circle it, and I'm going to make a note that that is point slope form. So far, so good. That's half of our objectives. Our second objective is to write our equation in slope-intercept form. Now, -2, 6 is not a y-intercept. It's not. -2, 6 is a point in quadrant 2. It's like, yay, okay, great. So what we're actually going to do to find slope-intercept form is we're going to rewrite point slope. So rewrite point slope, then solve for y. So let me show you. Y minus 6 is equal to 3 times x plus 2. If we wanted to take this through our next logical step, remember we're just always trying to take a step forward, we would say, I want to drop parentheses, right? I want to drop parentheses by distributing the 3 so that I can open everything up. And I would say, yeah, let's do it. So we have y minus 6 is equal to 3 times x, which is 3x, and then 3 times positive 2, which is positive 6. Now, recall that we want our equation in slope-intercept form, which means y equals mx plus b. So if it helps, I'm going to write y equals mx plus b above slope-intercept form, just so it could be a reminder that we want y by itself. Okay. If I want to get y isolated, I'm now going to add the 6 to both sides. By bringing the 6 over, Notice these cancel each other out, leaving us with y equals, and then all we have to do is bring down the 3x and combine our like terms. 6 plus 6 is 12, and there is slope-intercept form. Let's label it. That's all we have to do. So as a recap, if you're just given a slope and a point, use point slope. From point slope, solve for y, and you've just found slope-intercept form. That's the format you're always going to go. Point slope, solve for y, slope-intercept. Always, okay? Unless for some reason you're given the slope and the y-intercept initially, then sure, you could just write slope-intercept form. But chances are that won't be the case. So you need to get into the mindset that if you do not have a y-intercept, but you have some random point slope, solve for y, slope-intercept, okay? And again, you will see questions where you're not given the slope at all. You just have to calculate it. That's an extra step. So calculate slope, point slope, slope-intercept. Let's see it. Turning the page. Write the equation of a line in point slope form and in slope-intercept form given the following conditions. So number 1, we have a slope of -2/3 going through the point 3, -4. Point slope. Duh, right? I want this to be like a duh moment for you. So xy, let's call that x1, y1, because that's our first point. Even though it is our only point, I'm still going to call it x1, y1. Again, point slope form. Let's write it out. Point slope form is y minus y1 is equal to m times x minus x1. We are going to plug in our values. So we have y minus, y1 is -4. So if we have y minus -4, do you agree that y minus a -4 is the same as y plus 4? Good. Y plus 4 is equal to our slope, which is m, is a -2/3, so we're going to plug that in. Parentheses, x minus, and then x1 in this case is a 3. So x minus a +3 is just x minus 3. And there is point slope. Okay, I don't mean to rotate the page, but I want to make life easier for me. Sorry, not sorry. Okay, so point slope form, y plus 4 is equal to -2/3 times x minus 3. Super cool. We need to continue. So we're going to take this form and solve for y. By doing that, we will then get our slope-intercept form. So I'm going to rewrite it. Y plus 4 is equal to -2/3 times x minus 3. If we're going to take a step further, we want to say, well, I would have to distribute that -2/3 so that I could drop the parentheses. So let's do it. We have y plus 4 is equal to -2/3 times x is just a -2/3 x. A -2/3 times a -3, well, first, a negative times a negative is a positive, right? We need to make sure that we're careful with our signs. A negative times a negative is a positive. And then 2/3 times 3/1, remember, if it helps, you can write it over 1. 2/3 times 3/1, well, these 3's are going to cancel, right? They divide out. So if you divide 3 into 3 and 3 into 3, you're left with 1 and 1. So that leaves me with 2 times 1, which is 2. Next, I need to focus on getting y alone. So I'm going to subtract 4. What you do to one side, do to the other side of the equals. These two terms are opposites. They eliminate each other. So y is equal to, bring down the -2/3 x, and then 2 minus 4 is -2. And here we have slope-intercept form. The really cool thing about this is that we knew the slope was a negative 2/3, that was a given, but now we know what the y-intercept is. The y-intercept for our equation for the line with a slope of negative 2/3 going through the point 3, -4 has a y-intercept of 0, -2. It's kind of cool, right? You could just pull this information once you actually write out the equation. Okay, look at number 2. This time, we want to write the equation in point-slope form and slope-intercept form, going through the points 0, 4, and -1, -3. Aha! This is the one that I was referring to, where if you are not provided with the slope, you have to calculate the slope. Okay? So step number 1 in this case would be, we need to find the slope. Okay, we could do this a couple ways. We can actually plot the 2 points on a graph and then connect them with a line and then count, what that slope is. So we could do this graphically. If you don't have graph paper handy, then you may as well just do this algebraically. So we're going to need this slope formula first. So to calculate the slope, m is equal to y2 minus y1 over x2 minus x1. Do you remember that formula? y2 minus y1 over x2 minus x1, which means we need to call this x1 y1, x2 y2. All right. Remember, this is just a recap of what we've done earlier in this unit. Okay, let's use a formula. So y2 is a -3 minus y1, which is 4, over x2, which is -1, minus x1, which is 0. Good, so we have -3 minus 4 over -1 minus 0. -3 minus 4 is a -7. -1 minus 0 is a -1. And of course, a -7 divided by -1 is a +7. You can write 7 over 1 if you would like, but you definitely have to clean up the signs. A negative divided by a negative is a positive. Be very careful, be critical about these signs. I don't want you to lose points just because you accidentally wrote the wrong sign. Okay? So m is equal to 7. So we know that our slope is 7 and our x1, y1 is 0, 4. While I'm going through this process, can anyone write in the chat something that they notice about this ordered pair? But I'm going to continue, but once you notice it, add that to the chat. So we need to write our equations in both point-slope form and in slope-intercept form. So we're going to begin by using the y minus y1 is equal to m times x minus x1, or point-slope form. We have y minus y1, which is 4, is equal to m, which is 7, times x minus x1, and x1 in this case is 0. Yes, Patrick, perfect. Patrick noticed this ordered pair 0, 4. This is the y-intercept. So what's really cool is that just given the slope and the y-intercept, I can actually write slope-intercept form. So I'm going to say slope-intercept form is y is equal to mx, so 7x plus b. And b is 4. So without even having to do anything with point slope, I was able to say, well, if this is a slope and Patrick told me that's the y-intercept, I can write the equation of the line in slope-intercept form. I still had to find point slope. So luckily, right here, this represents our point slope form. Now, here's one thing that I want you to be aware of. I want you all to recognize that we were given 2 ordered pairs for number 2. We were given the point 0, 4, which happened to be a y-intercept, and the point -1, -3. Now, if I connect those 2 points with a line, right? Here they are. They're connected with a line. Well, wouldn't it suffice to say that if I wanted point-slope form, that because both of those points belong to the same line, that I could use either of those points in my point-slope form? Let me show you what I mean by that. So what if instead I'm going to write point-slope form, but I'm going to use my second ordered pair, not the first one? So essentially what I'd end up having is y minus y2 is equal to m times x minus x2. So we'd have y minus a -3, but y minus a -3 is the same as y plus 3, is equal to 7. My slope is 7. And then x minus x2, but x2 is a -1, so x minus a -1 is +1. So believe it or not, but here's another form for my point-slope equation. Either of these equations is the correct answer for point-slope. Isn't that kind of cool that you can have more than one equation represent the same line? So both of these equations represent the same line. Now you're probably thinking, you know what? I don't really believe you. So I'm going to prove it to you right now. So what I'm going to do is I'm actually going to take both of these equations and I'm going to show you how this works. So check this out. So I'm going to write out y minus 4 is equal to 7 times x minus 0. There's the first point-slope equation. And I'm also going to write y plus 3 is equal to 7 times x plus 1. Okay, there it is. What I'm going to do now is I'm going to move forward in both of these to show you that it's the same line. Check this out. Let's distribute. Y minus 4 is equal to 7 times x, which is 7x. And then 7 times a -0 is 0. So if you want, I can write plus 0. I'm just going to write it there because I want to show you what's going to happen. We then add 4 to both sides, and we have y is equal to 7x plus 4. Wait. Slope-intercept form. Slope-intercept form. Okay. Let's do it again. Here's our second point-slope equation. We're going to distribute the 7. Y plus 3 is equal to 7x plus 7. We're going to subtract 3 from both sides, and we have y is equal to 7x plus 4. Wait, what? They're all the same? Yes. This is further proof that you can use either ordered pair, the first one or the second one, in your point-slope form to find that point-slope equation, because either way, they belong to the same line. They may look different, but they result in the exact same slope-intercept form. They result in exactly the same equation because they belong to the same line. So I want you to think about that as you progress through these problems. Okay? Make sense of this. Your turn. I would like you to do number 3. I would like you to find the equation of a line in point-slope form and slope-intercept form, given the following conditions. Going through the points 5, -2, and -3, -4. As soon as you're done, share that in the chat. Good luck. Okay, let's finish off by taking a look at this particular problem. So, the first thing I'm going to do is I'm going to label my first ordered pair x1, y1. I'm going to label my second ordered pair x2, y2. Because I need point slope and slope intercept, I am hearing in both of those equations that I need the slope first. So m is equal to y2 minus y1 over x2 minus x1. So let's plug in. y2 is negative 4 minus y1, which is negative 2. x2 is negative 3 minus x1, which is 5. So far, so good? So we have negative 4 minus 2. So when we simplify this, if we had just written negative 4 plus 2, we would say that this is a negative 2. But negative 3 minus 5 is actually negative 8. We are then going to simplify this fraction. First, we notice a negative divided by a negative is a positive, so I'm just going to cancel those out. And then 2 over 8 reduces to 1 over 4. So for those of you who said that the slope was 1 over 4, excellent work, okay? So Noelia, Patrick, Ryan, beautiful work on the slope being 1 over 4. Let's take it the next step. So we're going to use the first ordered pair. Honestly, we could use either one, but I'm going to use the first ordered pair in my point slope. Point slope form. I'm going to write it out again. So point slope form is y minus y1 equals m parentheses x minus x1. y1 is negative 2, so y minus a negative 2. Y minus a negative 2 is the same as y plus 2, so I'm just going to clean that up right away. M is 1 over 4, and then we have x minus x1, and x1 is 5. So x minus 5. Again, excellent work to everyone who has identified that point slope is y plus 2 is equal to a fourth times x minus 5. Yes, exactly, Patrick. Kevin, and that's okay. It's a small error. Just be really, really, really careful with your signs. Be careful with how you write it out. And remember, you're not multiplying. You're just combining like terms. So negative 4 plus 2 and then negative 3 minus 5. Say it out loud. I think if you read it out loud, you'll hear the operations and you'll be able to move forward without making an error. Okay, so we have point slope form. Again, I apologize for shifting the paper. So here is my solution. Remember, I could have two answers. Here's my first one. My second point slope form, and again, this is just if you wanted to write it out. My second point slope form could be y minus y2. y2 is negative 4, so it's going to be y plus 4 is equal to my slope, which is 1/4, times x minus, and then x2 is a negative 3, so x minus minus 3 is x plus 3. So either equation would be sufficient for point slope form, okay, because we're referencing the same line. We're just using a different starting point. All right, now I'm going to rewrite point slope form, and I'm going to use this first one. So we have y plus 2 is equal to 1/4 times x minus 5. Here is where we proceed by distributing. 1/4 times x is 1/4 x. 1/4 times negative 5 is negative 5/4. If you are still kind of struggling a little bit with fractions, remember you could always write the number over a 1. Think about 1/4 times negative 5/1 is a negative 5/4. Okay, just multiply. Numerator times numerator over denominator times denominator. Next, I need to isolate my y, so I'm going to subtract 2 from both sides. That leaves me with y is equal to 1/4 x, and then this is the part where we have to do a little bit of side work. I mean, not that we have to, but I'm going to show you how to do this again by hand. So we have negative 5/4 minus 2. Remember, that's 2/1. It's an integer. So when I add or subtract fractions, I need a common denominator. So my LCD in this case is 4. We do not multiply by 4 because this is not an equation. We're simply combining like terms in this particular side work expression. So I'm going to multiply by 4 in the denominator and the numerator. This gives me negative 5/4 minus 8/4. So far, so good. Next, I'm going to combine these. So a -5 and a -8 gives me a -13, and keep the denominator -13/4. So excellent work. Patrick, nicely done. Nicely done. Ryan, nicely done. And Noelia, nicely done as well. Thank you so much for sharing all of your work. So your slope-intercept form is y is equal to 1/4 x minus 13/4. All right, everyone. Have a wonderful weekend. Bye.